Welcome to IBM's Modular Datacenter here in Denmark. This is one of the few that IBM has deployed in this country. This particular data center has a PUE of 1.15 at full load. This is average PUE throughout the year. And thanks to the natural free cooling technology and the favorable climate conditions that can be achieved in Denmark. This modular data center, as you may see, is made out of several ISO containers. Some devoted to power and cooling, some for IT, and few for the natural free cooling and also for the gensets. The IT modules behind me can host up to 30 racks with a total maximum IT power of 200 kilowatts. They are cooled by these natural free cooling modules, which are also N+1 redundant. And thanks to this cooling technology, we are able to run this data center in a very, very high energy efficiency mode. The cold corridor, where all the racks are placed, are fed by dual power busbars with an A and B power supply independently in a total tier 3 configuration. And all the racks are cooled by the natural free cooling system at the end, which is an attached module to this IT container module. This is the hot corridor area. This is the area where the two IT containers join. You can realize this is a seamless join, and also that racks are placed on rails, which are very easy to move back and forth, and provide enough space for service either on the back side or on the front side when engineers are loading up servers or are installing any machine. Also, power and data cables are managed through this flexible cable tray in order to avoid any sort of stress on the cables. And the hot air is collected by the natural free cooling system at the back end of this corridor in a separate module which is attached to the IT modules. Also, you may realize there is a VESDA very early detection system as well installed, as well as pressure sensors, temperature sensors, and relative humidity sensors. This is the power container, where we have a UPS-A and a UPS-B with dedicated batteries with 20-minute backup time, each of them, providing power to the IT modules that we saw before. We have also switchboards A and switchboard B as well, providing power to the entire facility, including natural free cooling systems and chillers. Also at the back end, we have the SCADA system managing over 400 signals, which control the entire facility. This is one of the two redundant motor generators that provide backup power to the entire data center facility. And each of them is 650 kVA and count with a 72-hour fuel tank with double pump. This is the natural free cooling module, which is attached to the IT modules and provide cooling in a very energy efficient way. This is commanded by some easy fans and a heat exchanger, which has all the benefits of a direct free cooling, but we prevent the risks of bringing external air into the IT room, and we prevent any risk associated with pollution or fire or smoke coming into the room, since we preserve the IT area totally independent from the external air. This is thanks to this heat exchanger, as I explained. The natural free cooling system is managed by the SCADA system, which controls different sensors: external temperature, external relative humidity, pressure in the IT cold corridor, temperature in the hot corridor. Based on all these parameters, the SCADA system will send signals to the easy fans to accelerate speed and increase the airflow or decrease it. This is the cooling backup module. This module contains chillers and dry coolers in order to provide chill water to reinforce the natural free cooling system for those days where temperature may raise to levels where natural free cooling is not effective enough. In this area, this is probably about 4% of the yearly hours. So here we are at another IBM Modular Data Center site, also in Denmark. And this is composed by 5 ISO 40 containers which provide hosting space for up to 70 racks with a total capacity of about 0.5 megawatt of IT power. All the operation is under a tier 3 configuration, including a dedicated power container, also 2 gensets fully redundant, and also, as you may see behind me, dedicated chiller container with the dry coolers on top. The IT containers are cooled by natural free cooling technology, also in a redundant configuration. This data center has been placed in a car parking location, which has helped enormously to speed up the deployment of the project and also to cut down the cost of the land where to place the data center, since we didn't have to look for a dedicated building or actually erect a new building. The 5 IT modules are joined side by side without any partition wall, creating a nice space, hosting up to 70 racks as mentioned before, and providing enough space for operators to install any type of IT equipment. This data center will go live in the next few weeks, and we are sure that will provide a magnificent service to its clients.
Summarizing the main benefits of AST modular data centers. Fast deployment, 12 to 18 weeks for modular versus 12 to 24 months for traditional. Reduced capex, build as you need approach, optimum utilization of real estate. Reduced OPEX, 20% to 40% improvements in energy efficiency thanks to AST modular proprietary natural free cooling technology. Plug and play, off-site constructed building blocks ready to be installed and relocated anywhere in the world. Project simplification, simplify complexity and risk associated to traditional construction. Flexible, adaptable to changing IT technologies and multi-tier. Fully integrated, includes 100% of all critical infrastructure needed for an always-on data center.
Today we have introduced you a new generation of modular data centers, with 3 key benefits: rapid deployment, scalable, and very energy efficient. I hope you enjoyed the tour. Thank you.